Hello everyone, my name is Florin and this is the demo for task 1 for 301 CR. So here I have a model. It's a model of a hand. As you can see, it's a very simple hand. It doesn't have anything else other than the fingers and a fictional palm. I've decided to draw only the palm bones so you can see the fingers at all times. So the purpose of this task was to create a model that can be rotated around different axes, moved on different axes. So if you can see here, I'm moving the object on the z-axis, here I'm moving it on the x-axis, and here I'm moving it on the y-axis. You can see on the top left corner an indicator showing which axis it's pointing where. So this is how you move them around. And you can individually control each finger of the hand. So if I zoom in, or actually if I scale the object by pressing S, I can bring it closer. The hand has a couple of controls, so as you can see on the right side here I have a list with all of them. It's quite hard to remember them. So the first thing you can do with the hand, you can basically bend all the fingers. So this is the first joint, the place where the finger is connected to the palm. The second one you can control is obviously next joint and the final joint, which is controlled like this. However, what's special about this hand is that you can control individual fingers. So in this case, if you press 1, 2, 3, 4 and 5, you can activate and deactivate them. So if I press 1 and 3, no, and 4 and 5, I have deactivated fingers 1, 4 and 5. And then I can control the remaining 2 fingers to make something like a peace sign or whatever you feel that you want to do. This is about all that the model can do. You can move individual fingers, you can deactivate whatever fingers, you can reactivate them. It's up to you how you want to control the hand. It's up to the user. So in this case, I'm just leaving one finger up, and then I'm just activating some other fingers and moving them, just so you can see each one of them can be controlled. The second part of this demo is the particle generator. So for this one, I'll reset my scene. Here we have to create a particle generator that can be controlled. And by control, I mean we're supposed to have something that controls the generation rate. So that one will be controlled by plus and minus. So as you can see, now you can see each particle being generated. While if I press on plus, you don't actually see each one. You see a stream of particles coming out. You can do some other stuff with it as well. You can increase the scatter size. So if you notice, the stream is getting wider, let's say. So if I zoom in, you can see how this is actually wider than the flow we saw initially. You can also control the stream. You can move it around, so you can change its position. You can do this by pressing U to control the x-axis. You can press I to control the y-axis, and you can press O to control the z-axis. So the other goal of this demo was to show collision detection between the particles and other objects. So in this case I have collision with the spheres, and this is done by actually calculating the distance between each particle and the center of each particle and the center of the spheres. And if the distance is found to be smaller or equal to the distance, to the sum of the radius of the particle and of the sphere, then the collision will be triggered. Another collision detection was created for planes as well, so you can add custom planes defined by 3 points. So if I move this one, just reset the scene, and if I move this one here, you will see the actual particles are starting to stick to a plane. The collision with the plane is set so when the particle meets it, it will stop there. So it's easier to see in the demo. So if I move around, you'll see how they sort of stop until they're being removed by the generator. There's another plane here. If I go, yeah, just reset the camera. So if I lower this a bit more, you'll see how they start sticking to horizontal plane. Right about here. So if I increase the scatter and move them back a bit, you see how the particles stick to both of the planes. So this one works as asked in the task description. You can set up planes. So to set up a plane, you have to use a 3-point definition of the plane, which can be seen here. So you have 3 points defining the plane, and then the actual particles that CPP, my particle system, that CPP system will calculate the distance to either a sphere or a plane, as you wish. This was my demo for task 1 and 2, and I'll see you for the next task soon.